In this video, we're going to use Gaussian elimination with back substitution to solve systems of linear equations. So, I have already written what REF form would look like for a 2 by 2 matrix. Okay? So now what I would like to be able to do is to write out this system of equations using the augmented matrix. Now, in REF, we have 1 in the top left corner. As of right now, we do not have that. But notice there is a 1 as the first element in the second row. So what am I going to do? I'm going to switch row 1 and row 2. Now, notice I need this 2 to be a 0. So I'm going to use row 1 for this. So what can I multiply row 2 by and add it to row 1 to make that 2 a 0? Well, if I take the 1 that's right above it and multiply it by -2 and add it to the 2, we know that's going to be 0. So what are we going to do? We'll take -2 R1 plus R2, and that's going to be my new row 2. So let's do the row operation underneath here. So we've got -2 times 1 plus 2 is 0. We have -2 times 1 plus a -1 is equal to -3. And 2 times 5 plus 1 is -9. So those numbers are going to be the new row 2. So rewrite. We did nothing to row 1. And now I'm going to replace row 2. Now, notice in REF, this particular value needs to be a 1. Now, if I do row 1, the problem is with that 1 on the top left, it's going to change that 0 to something else. So I'm not going to use row 1 at all for this part of the problem. So what are my other options? Well, my other option is I can multiply the entire second row by -1/3. And now that -3 should end up being a 1. So again, row 1 doesn't change. And now row 2. Now we are in REF form. So underneath, I'm going to write the system of equations. Okay. Again, back substitution, I can replace this y with a 3. Solve, that's x equal to 2. So the solution of this system, x comma y, is 2, 3. Easy to plug in. 2 times 2 is 4, minus 3 is 1, and 2 plus 3 is 5. All right, so let's do one example then with a system of 3 equations and 3 variables. Now, I've already written what REF form is going to look like. 1 in the main diagonals, 0s underneath, and above the 1s and the answer column, we don't care what that's going to be. So first of all, let's write out the augmented matrix for this. Now, notice in this case, the 1 is in the top left-hand corner. So now what I want to do is to get rid of this 2 and make it a 0, and this 3 and make that a 0. So I'm going to use row 1 for both. So let's start with the -2. What do I multiply the first row by and add it to the second row to make that -2 a 0? Well, in this case, we're going to do 2. So 2 times row 1 plus row 2 is going to be my new row 2. Now, using row 1 again, what do I multiply row 1 by and add it to row 3 to make that 3 a 0? In this case, we'll do -3. Okay, so let's do one row operation for this on the side. So what do we have? We've got 2 times 1 plus a -2 is 0. We've got 2 times -1 plus 5 is 3. 2 times -2 plus 10 is 6. And 2 times 0 plus -3 is -3. Now, I'm going to do the other row operation underneath. So negative 3 times 1 plus 3 is 0. Negative 3 times negative 1 plus 1, that is 4. Negative 3 times a negative 2 plus 0 is 6. And negative 3 times 0 plus 0 is 0. Okay? So now below, I'm going to write the new matrix. Okay? Now again, row 1 I haven't touched. I'll leave alone. Row 2 now is 0, 3, 6, and negative 3. And row 3 is 0, 4, 6, 0. So now the first column for this is completely done. So now let's go to the second column. This 3 here needs to be a 1. Okay? So what's one way I can do this? I can multiply the second row by 1/3. So again, the other two rows are not affected now. Now that I've got the 1 where it belongs, now underneath I need this 4 to be a 0. Now I will not use row 1 because with the 1 and the 0 that is already there, that's going to change that 0 into something else. So I'm going to use row 2 with row 3 because 0 times anything plus 0 still 0. So what am I going to multiply row 2 by and add it to row 3 to make that 4 a 0? Well, in this case, we're going to use negative 4. Negative 4 R2 plus R3 is a new R3. So right underneath, I will do this row operation. So negative 4 times 0 plus 0 is 0. That's good. We want that 0 to be there. Negative 4 times 1 plus 4 is 0. Negative 4 times 2 plus 6, that's negative 2. And negative 4 times negative 1 plus 0 is 4. So those are going to be my new elements for row 3. So again, row 1, not changed. Row 2, not changed. Row 3 is what I need to change. Now, the first two columns are done. For the third column, I need that negative 2 to be a 1. So how can I do that? I can multiply the third row by negative a half. So write the new matrix. In fact, we will do that below. Now I am in REF form. Okay? So now I can write out these three equations. So again, I can use back substitution for this. I can replace this z with negative 2, so I can solve for y. So y is equal to 3. Now, what can I do? I can use y for 3 and z for negative 2 to solve the top equation for x. Okay, let me scroll down a little bit. Now, write it as an ordered triplet. Remember, x, then y, then z. And that is my solution to the system. Now, again, I would advise to check to make sure that ordered triplet is a solution to every equation that's in the original system. So I will let you do that on your own. All right, the last thing I want to talk about in this video, anytime you have more variables and equations, most of the time you will have infinitely many solutions. Okay, but that isn't the only time that you're going to have an infinite number of solutions. So let's take a look at this example here. Notice the bottom equation, 0 equal to 0. That's immediately telling me infinitely many solutions, which means I need to write my solutions parametrically. Okay? So how do I do that? Well, rewrite the other two equations. Okay? Now, both of the equations have z's. So I'm going to solve the top equation for x in terms of z, and I'm going to solve the bottom equation for y in terms of z. So for the top, that's easy. And for the bottom, just as easy. Now remember, your solution is x, y, z. So how do I rewrite it? Well, x now is 41 plus 4z. Y is now 31 plus 3z. And z is in terms of z. Okay? So that is my solution to this system. Again, do not put all real numbers. For instance, if I plug in z for 0, 0, 0, 0 is not a solution to that system. Okay? Yes, you have infinitely many solutions, but it is not all real numbers. Okay, take a look at the last example. Here, how many solutions does this system have? Well, the answer to that question, again, is looking at the bottom row. We have something of 0 equal to -5. This system of equations has no solution. So sometimes I can look at matrices very quickly, not have to do any row operations, and determine very quickly how many solutions the system is going to have.